you all see my screen?
Yeah.
Yeah. Yeah. Great. It's 40 now. 1 minute more. I don't expect anyone. 28. Okay. Okay, someone joined. Someone else joined. 40. Okay, great. First of all, welcome to the new guys who joined today, and thanks for joining. And thanks, obviously, the people who already are attending regularly my sessions. I believe it is useful to them and helping them to learn and understand. By the way, whether just wanted to check.
And by the way, Prabhat Mahapatra is also here. We are in the same session in one place.
Okay, great. So I just wanted to check. Last time we answered some of the ASG talks. So I'm Amay. Is Amay right? Is he present?
Yeah, I'm here.
Okay, great. I wanted to just check.
Yep.
Okay, tomorrow we'll discuss some other things. Okay.
Sure.
Of your doubts. Okay. Who else joined? Okay, great. So again, that's why. Thanks again, everybody. We'll move ahead. Okay. And today's agenda is to talk about Docker containers, and because obviously everybody now and then you are hearing maybe every day in your job about Docker containers, if not Docker, at least containers, Kubernetes, microservices. These are the common topics in around whether it is development, whether it is cloud, whether it is DevOps, anything, containers, right? That's a common word in all the IT. So what is that? Why it is so famous and why it is so required and what are the advantages? So that's all we're going to see today, okay? I'm sure many of you will not be new to containers, but because of some of you are new, so I would like to go to very basics, and so that people who are new to containers, because many people asked, I think, what is the basic requirements to learn about containers? I would request you mute, please. Yeah. Okay, great. So some of you asked in the chat, what is the prerequisite or what is the requirement to learn containers? I said nothing, because I'm going to cover almost the basics. And I'm sure we all are from IT background. So I assume that you obviously know how to operate Windows or Linux. Linux is better. Even if you are Windows, should not be matter too. So because the concepts are pretty much the same. Okay. So just wanted to give one definition. There are two things we are going to talk here today. One is a Docker container. Another is a container image. Okay. So these are the two important things. And also we'll see what they are, what are the differences between them, and what they're used, where they're used, and how they are used. Okay. How, why, and where. These are some of the answers we'll get it today. Okay, before jumping into in-depth Docker containers. So this is something I have directly picked up from Docker site. This is the definition they have given in their website. What are all Docker containers, right? So they say, everybody says, a container is a standard unit of software that packages up code and its dependencies, all its dependencies, not just dependencies. So the application runs quickly and reliably from one computing environment to another. Let's understand this definition. So it is nothing but a standard unit of software. That means it is just a packaged software that we know. And what are the packages? What it contains? Code. That means if you are packaging one application, obviously you have already codified it and you have the executable, right? You have the executable and its dependencies. That means when you are, let it be a Java file or jar file, obviously when you compile it, it will create a jar file. That means the jar file and its dependencies. What are the dependency of jar file? Obviously, it expects your code expects some more jar files to be associated with it also. It may require some of the other jar files too. So those dependency also has to be there. And obviously, it expects a JVM to run. That means the JVM also has to be packaged, right? And do you need the operating system? Because that is a dependency, right? Yes, we don't package the whole operating system into a Docker container, but part of the operating system, like some of the dependencies libraries of the operating system will be packaged. So that is what we call the base image sometimes. So here that means the code, the executable code, and the runtime. Sometimes the dependency is the nothing but the runtime, and some of the OS libraries and configuration files are packaged together into one piece of software, and so that it can run quickly and reliably from one computing environment to another. That means the last point, remember, one computing environment to another. That means once it is packaged, it should run in every environment. Okay, when I say every environment means obviously if you have packaged it on a Windows environment, it's not going to run on Linux. But there is another thing. If you have packaged it on CentOS or Red Hat Linux, it is going to run on Ubuntu. In Linux, it is not going to change actually. If you have packaged it using Ubuntu, it is going to run on Red Hat. It is going to run in other Linux operating system also. Okay, but it cannot change between like Windows to Linux or Linux to Windows. But whereas if in Windows different environments, sorry, in Linux it is, if it is the OS is different, it can run. Okay, so that's what is the Docker container. Then let's talk about what is a Docker container image. So image is nothing but once we package it, right? Once everything is packaged together, that is being saved somewhere so that the portability will be very, very high. That means it is like a zip file, you take it. Why there is a zip file or jar file? Because of the portability, right? That means it is a single file. You can take it anywhere you want. So in the previous generation of software development, if you see, before containers I'm talking, when we used to develop our old timers, right? I'm talking about 2005 or so, uh, where container was not there. In fact, 2005, we started containers. When I started, literally I mean we. I was part of the Sun Microsystems Solaris operating system group. And in Solaris 10, 2005, in fact, Sun Microsystem created the first containers of the world in Solaris. They used to call it Solaris zones. And I'm from the same team, by the way. So in 2005, Sun Microsystem created the first containers of the world using Solaris zones. So later it came as Docker, changed it differently. Obviously they made it a bit more easier, but containers started from around that time, 2004, 2005. So I'm talking about previous to 2004, 2005, what we used to do is, we used to develop the software, then we used to send the jar file maybe to the customer or any application developers. I'm sure you all are from application development. or system development, whatever. So when you develop a software, you create an executable and you configure in your test development environment. Then obviously you ask your testing team how to configure it in their environment to test it. Then again, you send it to the client or customer in a production environment, how they will configure it. Sometimes there will be some discrepancies in configuration and it may not run, it will have some issues, so that you will tell that how to reproduce. The customer says, okay, how to reproduce the issue. Exactly same configuration has to be there. I was part of it. Suppose Solaris is not running, some software is running, how to reproduce it, you used to ask the client how to reproduce it, what are the exact configurations. So that was a huge issue, do you remember? But what it happens with containers is the configuration is not going to change in any way. Once it is configured in your dev environment, exactly the same configuration will be there in the test environment, and exactly the same configuration will be at the production environment also. That means once it's packaged, it becomes immutable. Remember this? It is called immutable. Once it is packaged, it cannot be modified because the configuration is also packaged. So one of the big properties or good properties or advantageous property of container is it is immutable once packaged. So that's what is the image. Image is nothing but a software which is the unit of software. Once it's packaged and uh, achieved, the package is achieved, it is an image and it's saved somewhere, and it can be ported. It can be ported to different places, environment, and it can be, but what are the things it packages? Again, the application code, runtime, system tools, system libraries, and settings. But so the image and container, the difference is image is simple static uh, packaged software. Container is nothing but when it is running. It's runtime. Once the uh, image is running, that becomes a container. That's the, you can see, you to visualize that way. Okay, so let's go to the next. Is there before going, is there any doubt or is there any question? I want to really clear some of the doubts before we move ahead. Please, anybody, you're free to ask. Okay.
Pancha, Sujit here. And just one question. This package can be used in all the environments, right? Like test, production, and UAT, or whatever the environment. So, how do they configure the environment while packaging it?
So that's creation of the Docker image that we'll cover in the following slides. Okay, that is because when I say configured means in the during dev environment, while creating the image, it is configured. That means a developer, when he creates a container or image, Docker image, he configures it that what will be its runtime configuration irrespective of where it is run.
So, Pancha, this is Vivek. Just one question, just on the back of the previous question. Say we have dependencies with a database or with MQ or anything.
Mm-hmm.
So, from a packaging perspective, you are going to include the runtime libraries that might be required. But say the queue manager, the queue name, the database credentials, and everything else, if that is part of the settings, how does the developer ensure that that is taken care of?
Very good question. Okay, so in fact, those are all, the name is will be constant. That means what are all the like variables it is going to use specific to particular configuration cannot be modified. Whereas those variables exact name, once you package the software or create an image, you have to create a document that these are the maybe environment variables has to be set at the Docker host before it is run. That means you will define your Docker image that what are the variables it will expect from the local host, okay, or the running host. So those you can either, there are multiple ways to do that. You can simple create environment variable and export it, or you can create a file, okay, and save it, and that can be mapped to a running environment, a running Docker container. That is called volume mapping. So that means your local file system and the Docker container file system will be mapped so that it can read during runtime, it can read from your local file system and it will get all the variables, whatever it needs. There are multiple ways to do that, we'll cover, but that is a very good question. Okay, so let's see what are the advantages of containers over VM. So because we are almost running on the cloud or the previously virtualization, everything almost VMs. What we are seeing in the cloud, in fact, AWS, we have seen how we can create instances. The instances are nothing but the virtual machines we're creating and running. We saw in our cloud class how to run a WordPress using a web server and a database server, and we combine together. Those are the VMs, right? So what are the advantages over VM? So before coming to this, I want to show some of the slides, following 3 slides and so, and I'll come back maybe to this. Let's understand some of the basics of the physical system first. So if you see here, this particular slide, I'll run this. When we have a physical system, then we have obviously the network, we have the storage, we have the hardware using whether it is processor, memory, IO, whatever. Then we install the operating system on it. I have here two separate physical machines, okay, connected to a network. So I'm talking about the left side. So physical, storage, hardware, operating system. Then obviously on the operating system, we have the runtime like Java runtime or .NET runtime. We call it actually .NET Core, and the .NET app or Java apps or any other cloud native application, sorry, OS native application like C, exe file or any Linux executables, right? So this is a simple physical environment which nobody uses now, unless it is really required, which previous year and previous generation of applications used to run that. We call it now legacy applications, right? So now in the cloud world, when it is infrastructure as a service came, infra as a service, IaaS, what we did is mostly either in the private cloud or in the hybrid cloud, what we did is we created hypervisor in between the operating system and the hardware. We inserted a hypervisor that all the cloud world, they have it, right? They have their own hypervisor. VMware has called ESXi, which is again a hypervisor. And here, in fact, when we create a virtual box also, that is a hypervisor, type 2 hypervisor. We saw how to install virtual box also, right? So on the virtual box, again, operating system, and we can have multiple VMs created. Then again, the same thing, and the JVM, .NET Core, and the Java apps. So this is, again, the virtual machines are cloud instances. They run it this way, right? So what was the basically issues with this kind of thing? We are pretty much okay with that, and it is almost dominated last 10 years of the IT world. Virtual machines, cloud, it dominated. So what was wrong in this kind of architecture or this kind of technology? So why we wanted to move to another new technology called Docker containers, right? So just wanted to check here, like here, obviously one point of view it is good because this is if you left side I'm talking about, they have set 2 virtual machine if you create. Obviously the isolation between them is excellent. In a VM environment, isolation of 2 VMs is obviously because there are separate operating system itself. So one operating system wants to talk to another, or one VM wants to talk to another, obviously they have to go through the hypervisor layer. or they have to go through the network. If this particular app is want to talk about this one, he has to go all the way to the network layer and come back to this, right? So one way it was better is good isolation. So obviously some good security also, right? One cannot read on others' applications without authorization that way. But we know that operating systems are a bit slow, because once it is down, suppose, then to restart a VM altogether, it takes some time. It is not fast enough. And also, it has to take a lot of system resources to start the operating system. That means even sometimes you don't want to use those resources, but you are still forced to utilize those resources. So the overhead of a VM virtual machine is pretty much high. Sometimes you don't need that. We just need to run an application. Why we need to run the whole operating system, right? That was another problem of VMs. That means it was slow and it has a lot of overheads. And because these are sometimes becomes massive, so sometimes the cost also is high. The cost of running a VM is high. So there are three things here. The obviously the overhead, the slowness, and the cost. There are other, obviously, if you start thinking, there will be multiple advantages and disadvantages will come, but these are some of the prominent disadvantages of the VM. And one advantage is because it is highly isolated, so it is highly secured. Once you secure your operating system, there is no way, if I log in this particular left side, I cannot go to here. Okay, so that is being changed in the Docker container environment. So what is changed? Let's see. Now, in the same operating system, VM operating system, what it does is we introduce between the hardware and the OS one layer called host hypervisor, right? So similarly, we introduced on and above the operating system, we introduced a layer called Docker engine. This is a Docker engine or Docker layer. So that will, again, it is sometimes called OS level virtualization or OS layer virtualization. That means it is not virtualizing the host, but it is virtualizing the operating system itself. So the app is just configured on the Docker container as a Docker image, and it is being run. So obviously, you can see here, we see the app, or the containers sometimes do share some of the operating system resources, like the OS kernel, some of the libraries, some of the OS configurations are being shared by different containers in the same host, if there happens to be in the same host. Obviously, a container like container 1 and container 3, they don't share because they are in two different VMs. But if you see container 1 and container 2, they do share some of the operating systems, libraries, and kernel. So we'll not go, this is going to that detail is out of scope for this session. We'll focus more on the usefulness, and I don't want to go deeper, but that's sometimes I wanted to point out. Okay. Then I'll come back to the slide which we are discussing here.
Can I ask a question?
Yes, please.
Is there a hypervisor required in that model, or can the Docker just be installed directly on the?
In fact, some of the Dockers nowadays can be directly implemented on a hardware. That much advantage has been done. Because I wanted to take this model, because obviously when it comes to cloud, right? I'm talking about in a cloud world. Obviously, this is the model they follow. They cannot, obviously, they're not directly implementing on a hardware. They have a VM, they're creating a VM, and on the VM, they're creating the containers. But of course, it is possible nowadays, you can call physical containers, that you can directly implement containers on a physical machine. But obviously, there will be operating system has to be there. So directly you can install, like simple example, if I take your Windows laptop, if you create Docker in there on the operating system itself and remove all the unnecessary things what you don't need, it becomes kind of directly running containers on your laptop on the hardware itself, right? That's one. It's a bad example, but it's also can be one simple example. Okay.
Okay. Yep.
But let's see what are the advantages again. I said I'll come back. So as I already explained, less overhead, because obviously it is not a massive VM. So that whole operating system has to be created. So less overhead. Quicker spinning, I said, because it is already packaged. All the dependencies, all the configurations, all the required libraries are already packaged. So it does not have to configure during runtime. So it runs quicker. Using a second, you can run a container. Whereas VMs takes, because all the resources has to be allocated, memory has to be allocated, everything operating system wants to run, then it loads libraries, then it loads the JVM, then it loads the .NET Core, then it learns the application libraries, then it runs the configuration of the software, then it runs the code. So obviously it is not that fast. In today's world, we want to like quickly do everything. So containers are quicker than VMs. Increased portability. That's when I said portability means once it is packaged, it is like you can take it to anywhere you like. And that's why if you see Docker Hub is a registry, right? Publicly available Docker registry environment where you can find n number of people there creating simple containers and putting it there as images, and anybody can download it and directly run it without any modification. So portability becomes really high, which is I really appreciate that Docker, though Sun Microsystem created the containers, but they didn't make it so easy to use. And obviously that's why they went out of business. But though the technology is high, that the technology was really big and good, but the easy of use was never done, I believe so. So, and Docker did a very nice job of making it easier to use. That's why it became hot, okay? So more consistent operation. That's why I said consistent means like in a DevOps world, whether it's a dev environment, test environment, or production environment, it's going to be very consistent because it is once packaged, it's not going to change. You don't need to configure separately for separate environments. Efficiency, obviously, because less, that once it is created, it does not need to be patched, right? So it is obviously, and it is rapid, less overhead, quicker, so obviously high efficient. Security, because once it is created, you know that if it is packaged, that's why this is important, I said, immutable property of a container or image. So once it is packaged, it cannot be modified. But whereas if you want to modify it, what you do is you run it, create another layer upon it, again repackage it. But existing image will not be modified. Let me be very clear about it. That sometimes we call it, hey, how you call immutable? That means it cannot be changed. I have changed a Docker container. Yes, you have changed, but you have not changed the underlying container. You have created another layer and repackaged and create altogether a new image. That's how it is created. You are not modifying the original image. What you take is, you take the original image, then again run it, and while it is running, you create another set of software and reconfigure it, and then again repackage it and create another image. And that becomes container version 2 maybe. So that becomes again immutable. It can, once it is packaged, it cannot be modified. So it is obviously once you package, that means you know that what is inside. It cannot be modified. So any separate code cannot get into a container once it is packaged. So it is secure, okay? A running container never changes, simple. Then obviously better application development. and it supports Agile because it is small and it is quick, it is portable. So obviously it supports good Agile framework and Agile development. Any doubt? Again. Okay. So I discussed about this and this one, right? Thank you for watching. See you in my next video. And please do subscribe to my channel and encourage me to create more training contents. Thank you.